Hi, welcome to the BDP ICP 14. This is ICP is about Apache Spark machine learning libraries to analyze the machine learning algorithms using PySpark ML libraries is the main objective of this ICP. Softwares that are required is PySpark, Python 3 and Jupyter Notebook. First, for setting up, we have to install PySpark find Spark, and we have to just initialize PySpark at the first initial position. Then we have to create a Spark session. Um, Spark session and import all the machine learning libraries that are required. The first step is to load the data from the CSV file into the data frame into a data frame. So the first step is creating the data frame. This is the data frame that we have created, and then the next step is like converting all the necessary object parameters to integer type. So whatever that are the numbers that are there of instant type, they will be converted into integer type. So the next step is like printing the schema over here. Then the next step is like creating a column called label, in on which we are going to take it as a target throughout the experiment, like throughout the ICP. We are just replacing the hours per week into the label part, and then the printing the schema over here. Then the next step is like the next step, we are assembling and transforming the adult data over here. That is the data frame that we have created, that we are just transforming over here. So the next step is like after cleaning the data frame, the next step is performing the naive Bayes algorithm. So what is basically naive Bayes is like naive Bayes can be an algorithm that can be trained efficiently within uh, it computes the conditional probability distribution of each and every level, and then it applies the Bayes theorem to compute the conditional probability. uh, like if the probability of a factor is zero, then actually um, so it's basically to evaluate the models with the help of predictions. So for this, what we are doing is first we are randomly splitting the data over here into train and test. Then we are training the model using the naive Bayes algorithm, where we are setting the smoothing value as 1.0. So actually what this smoothing does is like basically in an unbalanced data set, there can be a lot of variation between the number of features, different features, which may cause disturbance in the probabilities. And the effect of minor probabilities on other features are also may also happen, which can be avoided with the help of increasing the smoothing value. So here we have taken two examples, where one we have set the smoothing as 1.0, and another I have set the smoothing value as 10.0. So based on this, I have trained my data set and calculated the accuracy. The accuracy is found out to be 0.0006, which is very negligible when the smoothing value is 1.0, and when it is 10.0, it is slightly increased. So when the smoothing value is increased, we can say that the testing accuracy is increased, which is because in an unbalanced data set of the smoothing value reduces the impact of heavily probable features, that is, be it highly probable or low probable. The impact of those kind of features on the other features can be reduced with the help of smoothing. So the next one is the decision tree classifier. The decision tree classifier is an algorithm that performs the recursive binary partition of the feature space. So it's basically it predicts the same label for each bottommost partition. So here we have performed the decision tree classifier, where again we have just fed the data into the model, and then performed the prediction, and then calculated the accuracy. The accuracy is found out to be 0.88, which is higher than naive Bayes. Then coming to the random forest classifier, here first splitting of datasets is performed, and then we are performing the feature transformation, and then we are preparing the data, and then the accuracy is calculated over here. Here also we are first fixing the training the data set, and then calculating the prediction and then accuracy over by there, and then the accuracy is found out to be 0.818, which is greater than naive bias, but then less than less than the decision tree. From this we can find that out of these three things, these three uh, these three classification algorithms, we can find that decision tree is the most accurate algorithm. Then the next question, coming to the next question, it is the next question is about clustering, that is K-means algorithm. So in this algorithm, so what we are doing is we are considering the diabetes data set, and we are using this vector assembler where we are taking all the columns in the diabetes data frame over here as the input columns, and then output columns we are setting it as features, and then we are using this seed value, like we are using the k value as 2 and as seed value as 1, and then fitting the data, and then we are performing the prediction and finding out the centers, like for we are just finding out the centers of all the of all the k values as predicted. The k, so set the k values are 2, so we are find out all the center values. The centers values I found out to be this one, and then the next one is like the next question is about regression. So here in the regression, this the first one is linear regression. So in the regression, actually, the regression is about performing, like we'll be. It is used to predict a binary outcome by using the um, binomial thing, so like binomial outputs. So here we have created a data frame using the given data set and then applied linear regression algorithm. So the first here also, like we have considered the input columns and output columns, and then transformed the assembler dot transform of this linear data df1 to we have assigned it to y, and then we have initialized the linear regression algorithm where the maximum iterations are set as 10, and the regression parameter is set as 0 0.3, and then we are fitting that to the model, and then calculating the coefficients and the intercepts, and the summary is below, and from here we have calculated the root mean square error and R2 factor of the model also. The RMSE is found to be 2.51 and R2 is 0.8. So the next step is like in the logistic regression. What we are doing is like we are creating a logistic data frame over here. On the same data frame that we have created for the linear regression, we are performing the same thing for logistic DF also. So the next one is again the same thing, like logistic regression is used to predict the binary output, like binary outcome. So here also we are fitting the model, training the model, and then calculating the coefficients and intercepts over here also. Um, so um, after doing this, we are calculating the multinomial coefficients as well as intercepts as well. So first, in the first thing, we calculated for binomial, and in the second thing we calculated for multinomial. So we have calculated both the equations as well as the intercepts for both the binomial and multinomial, and that's it. This is the end of the SAP. Thank you.